In this video, I will explain IoT architecture outline. Generally, IoT architecture refers to the triangle of components. Triangle means more number of components such as sensors, actuators, cloud services, protocols, and the layers that make up IoT networking system. IoT architecture consists of sensors, actuators, cloud services, protocols, and all of them are combined to form an IoT architecture. These sensors perform some actions, actuators perform some actions, cloud services perform some actions, protocols which are used to send protocols which are used to help the performing some tasks, and layers which make up IoT networking system. Here layers are playing an important role. It is divided into of the system. In order to perform that tasks, many tasks are involved in IoT architecture. With the help of layers only, how to perform tasks of the IoT architecture. Layers are playing an important role. The IoT architecture, the architecture of IoT is a four-step processing through which data flows from devices connected to sensors through a network, and then through the cloud for processing, analysis, and storage. Four layers are involved. The architecture of IoT is a four-step process through which data flows from devices connected to sensors through a network, and then through the cloud for processing, analysis, and storage. This is the four-stage IoT. This is the four-stage IoT architecture. First one is data gathering. That is called in the sensing layer. We use sensors and actuators. Data transmissions. We use internet gateways, network gateways, network technologies, data acquisition system, process information, data analytics, decision making, smart applications, smart application and management. All layers importance. All layers are playing important role in IoT architecture system. I will explain further. First one is a sensing layer. This one is a sensing layer. Sensors, actuators, devices are present in the sensing layers. Sensors, actuators, devices, IoT devices are present in the sensing layer. These sensors or actuators accept the data from the environment, physical environment, that creates some physical and environmental parameters. After that, process data and emits data over the net. Once the data is generated, the data is emits over network. Generally, in the sensing layer, we use the sensors and actuators. Sensors collect and analyze data from the environment in order to make it usable for further analysis. Sensors are used to sense the data from the environment. Actuators are involved in measuring the change recorded by the sensors. Actuators are also playing an important role, are involved in measuring the change recorded by the sensors. It is possible to connect sensors or actuators in a wired or wireless manner in order to perform sensing and actuation. By using a wireless technology or the wired technology, these sensors or actuators are connected. Generally, local area networks, personal area networks can be used to connecting sensors and actuators. This is the sensing layer importance. The sensors are color sensor, gas sensors, LDR sensor, proximity sensor, thermistor, smoke sensors, temperature sensor, rain sensor, PAR sensor, water flow sensor, gyroscope, ultrasonic sensor, humidity touch sensor, IR sensor, like that. These are some examples of the sensors. Next one is actuator. An actuator is a device that converts energy into motion. Electrical energy into mechanical energy. It does this by taking an electrical signal and combining it with an energy source. It does this by taking an electrical signal and combining it with an energy source. In an IoT system, the actuator can act on data collected by sensors. Sensors are used to sense the environmental conditions and collect some data. But the actuator can act on data collected by the sensors to create an outcome, to create an application as determined by the chosen settings of the user. Sensors are used to sense the environment and collect some data from the environment. The actuators are can act on data collected by sensors to create an application or outcome that is performed by the created by the user. Coming to next layer, this is the data gathering layer. Here in data gathering layers, we use sensors and actuators perform some tasks. Next one is a network layer. Second layer is a network layer. Internet/networking gateways, data acquisition system are present in the layer, in the network layer. Generally, we use gateways, internet gateways, network gateways. Data execution system, DAS, in the network layer are present in this layer. DAS, data acquisition system, performs data aggregation and conversion functions. That means collecting data and aggregate data, then convert analog data of sensor to digital data. Once these sensors are used to collect the data, by using in that network layer, we use the data aggregation system. With the help of that data aggregation system, performs data aggregation, conversion functions, collecting data and aggregate data, then converting analog data of sensor to digital data. analog data into analog to, here we use analog to digital converters. Analog to digital converters. Advanced gateways, which mainly opens up connection between sensor networks and the internet. Generally, we use advanced gateways. Definitely, we need some gateways, connect the sensor networks and the internet. Also perform many basic gateway functionalities like malware protections. Malware protection will protect the that third-party persons are not not entering into our communications. That is called as malware protections. Filtering. And the filtering also sometimes filtering. Also sometimes decision making based on input data. Decision making based on input data and the data management services. Next one is what is gateway? These are the devices, edge. These are the devices, sensors, which are used in the sensing layer. Cloud of IoT. The data stored in the cloud of IoT. IoT gateway is the access intermediate device between sensing layer and the application layer. Next, an IoT gateway is a physical device. Here, IoT gateway is a physical device or a software program that serves as the connection point between the cloud and the controllers, sensors, and intelligent devices. Connection point. IoT gateway acts as a connection point between cloud and controllers, sensors and intelligent devices. Sensors and intelligent devices. All data moving between IoT devices and the cloud passes through IoT gateway. These sensors in that sensing region, the data is developed, created. The data is sent to the IoT cloud. After so many steps, processing takes place. This data is passing through IoT gateway. All data moving between IoT device and the cloud passes through IoT gateway, which can be either a dedicated hardware appliance or software program. It can be a device or a software program. An IoT gateway might also be referred to as an intelligent gateway or a control tier. It is a mediator between IoT gateway is a hardware device or a piece of software program and acts as a mediator between sensing region and application layer, sensing layer and application layer. Next one. By the help of gateways, it is possible to establish device to device, device to cloud communication, machine to machine communication, and machine to application communication. IoT gateway enables a connection between sensor network and the internet, along with enabling IoT communication. It enables a connection between sensor network. This is the sensor network, sensor devices are there. Sensor network. Sensing devices are used here, sensors and actuators and IoT devices. It enables a connection between sensor network and internet. This one is internet. Along with enabling IoT communication, along with some IoT communication. IoT communication. It also performs many other tasks such as this IoT gateway performs protocols translations, aggregating the data. Protocol translation means some applications we use some protocols in order to provide compatibility. We use some protocols translation. Aggregating all the data. Aggregating all the data means different sensors are used to sense the environmental conditions, generates different types of data. The main function of IoT gateway is aggregating all the data. Local processing and filtering of data. Process the data and filter the data before sending it to cloud. Before sending it to cloud. Raw data is converted into smooth data. IoT gateway is the main function is raw data is converted into smooth data and then sent to cloud. Locally storing data and autonomously controlling devices based on some input data, providing additional device security. Local storing data and autonomously controlling devices based on some input data. Okay, this is for security purpose. Generally, IoT device work with low power consumption. Without power, the devices are not working. Most of the IoT devices are battery operated. In IoT, as IoT device work with low power consumption battery power. In other words, they are energy constraints. Energy constraint means IoT devices, most of the times IoT devices are involved in communications. Therefore, these devices are battery operated. Power is useful. Most of the times IoT devices are involved in communication. That data communication means sense the environmental condition, process the data, send the data, and like that. Receive the data like that. Therefore, the energy is wasted. Therefore, power is also wasted. That is called as energy constraint. So, if they will directly communicate to cloud without IoT gateway / internet, it won't be effective in terms of power. Without IoT gateway, it is not. It is very difficult. It is not. Without any IoT gateway, these IoT devices are not connected to IoT cloud because energy constraint. So they communicate with the gateway first using short range wireless transmission media networks like Zigbee, Bluetooth. So they consume less power for short range wireless transmission modes. For long range, or they can also be connected using long range like cellular communication and Wi-Fi, etc. By using some technologies, short range transmission mode technology like Zigbee, Bluetooth, and they can also be connected using long range like cellular and Wi-Fi technologies. The gateway links them to internet cloud by converting data into a standard protocol like message queuing telemetry transport protocol. Generally, the gateway links them to internet / cloud by converting data into standard protocol. By converting data into standard protocols like message queuing telemetry transport. Sensors are generates the data. Okay, these sensors are generates the data. The data is passing through IoT gateway, and then converting data into standard protocol like MQ MQTT, message queuing telemetry transport protocol. Using internet Wi-Fi, using not internet, Ethernet. Ethernet means cables. Using Ethernet cables, Wi-Fi/cellular or satellite connection. The gateway links them to internet/cloud by converting data into standard protocols like MQTT using Ethernet, Wi-Fi/cellular or satellite connection. And in mostly gateways mains powered unlike sensor nodes, which are battery powered. In mostly gateways, mains powered. Sensors are battery powered. Sensors are battery powered. In practice, there are multiple gateway devices. Generally, gateways are mains powered and sensors are battery operated. Let us think about a simple IoT gateway. Our smartphone comes into picture. It can also work as a IoT gateway. Our smartphone also works as a basic IoT gateway. When we use multiple radio technologies like our smart phone incorporated with some radio technologies like Wi-Fi, Bluetooth, cellular network of smartphone, to work on any IoT project in sensing and receiving data at the time. This also acts as a basic IoT gateway. Our smartphone incorporated with many radio technologies like Wi-Fi, Bluetooth, cellular network like that, and also acts as an sensing the IoT gateway, receiving the data, sensing the data to IoT cloud. Finally, key functionalities of IoT gateway: establishing communication bridge between sensing layer and application layer. That means in between sensors and cloud. Establishing communication bridge provides additional security. Protect the data from the third-party persons. Performs data aggregation. Different types of sensors are used to collect the data. All the data, we need some data aggregation. Processing and filtering the data, process the data, filter the data, remove unwanted data, that is called as filtration. Provides local stage as a cache or buffer. Sometimes some important data is stored in a local storage devices. Data computing at the edge level. Ability to manage entire device diagnostics and like that. These are the key functionalities of IoT device. Next, working of IoT device. IoT, not IoT device, IoT gateway. This one is IoT gateway. Receiving data from this one is a sensor network. This one is cloud application layer. Receives data from sensor network. IoT gateway receives data from the sensor network. Perform pre-processing, filtering, and cleaning on unfiltered data. Perform some after receiving the data. Perform some actions on the data. That is called as pre-processing, filtering, and cleaning on unfiltered data. Transports into standard protocols for communications. Transports into standard protocols for communications. Send after performing some actions, send the data to cloud. IoT gateway are key elements of IoT infrastructure as gateways. Establish a connection for communication and also perform other tasks described above. IoT gateway are key elements of IoT infrastructure as gateways. Establishing a connection for communication and also perform other tasks are described above. Next, coming to data acquisition system in that network layer. Data acquisition system can be used to convert analog data into digital forms. This is the physical phenomenon. Sensors are used to observe the surrounding conditions. Physical phenomenon, sensors, transducers, signal conditioning, analog to digital conversion, and then the data is applied to computer for processing, display, etc. Data execution system can be used to convert analog data into digital forms. It connects to the sensors and the actuators and gathering all the data, converting it to digital form so that it may be routed over the network by the internet gateway. With the help of that internet gateway, after conversion from analog to digital data, the data is sent to application cloud. It is responsible for data aggregation and conversion. We can also add additional features such as analytics and security to increase performance and efficiency. After conversion the data, we have to protect the data. We must protect the data. That is the additional features. You have to create. We have to add some security to the data. Data processing layer. Third one is the data processing layer. After network layer, this is processing unit of IoT ecosystem. Here data is analyzed and pre-processed before sending it to data center, from where data is accessed by software applications, often termed as business applications, where data is monitored and managed and further actions also prepared. So here Edge IT or Edge analytics come into picture. Edge IT system. The third stage of IoT architecture involves involves pre-processing and enhanced data analytics. In light of the significant amount of data collected by IoT systems and the consequent bandwidth requirements, Edge IT system play an important role, crucial role in reducing the pressure on the core IoT structure. Edge IoT system is also playing an important role because reduce the complexity, reduce the burden to the IoT infrastructures, core IoT infrastructure. Bandwidth also playing important. Edge IT system employs machine learning and visualization techniques. Machine learning nowadays, machine learning are playing an important role. Machine learning and visualization techniques to generate insights from collected data. Machine learning algorithms provides insights into data, while visualization techniques present the data in an easy to understand. By using these techniques, machine learning techniques and visualization techniques to generate insights from collected data. Suppose directly sending data to the server or the data center will cripple the speed of the system. Without this IoT gateway and without this edge system, suppose this data is directly sent to that IoT cloud, it is not desirable one. because speed of the operation decreases. Directly sending data to the server or the data center will cripple the speed of the system as well as the bandwidth of the local area network or routers. Analog data is generated at an enormous speed and will require a great deal of space. Therefore, it always recommended to convert the data into digital form. We must, for speed of operations, but for better storage conditions, convert this analog data into digital form. Most of the time, the data collected by the sensor actuators are not valuable to the organization. So only the important data is processed and transmitted to data centers and servers. Generally, this is the not valuable means analog form. So the important data is processed and transmitted to data centers and servers. All the data is not important. Only some important data is processed and sent to the data servers. Next, application layer. This is the last layer or fourth stage of the IoT architecture. Data centers are clouds in management storage the data, where data is managed and is used by the user application like agriculture, healthcare, aerospace, farming, defense, etc. Application layer. Data centers are cloud is management storage of data, where data is managed and is used by user applications like the data is stored in the cloud and it is utilized by the applications of the users like agriculture, healthcare, aerospace, framing, defense, etc. Data centers and cloud storage. After the data has been properly pre-processed and analyzed and all loopholes have been removed, the data is sent to the data centers and servers for final analysis and reporting. Okay. Data centers and the cloud services fall under the management services category and usually process data through analytics. Device management and security controls. Furthermore, the cloud also enables the transfer of data to end users. Applications like healthcare, retail environment, and emergency. This is the example. Machine-to-machine applications to client application domain. Machine-to-machine application means some sensors are used here. Some access network. In that network domain, we use some access network, wireless backhaul, core network, satellite. Device domain, the smart sensors, smart city, smart meter. This is the IoT gateway. All are explained clearly in the above. This one is all these are sensors. Consider this one. Patients, health condition monitoring. We use glucose, protein, motion sensors, oxygen, blood pressure, like that. Some sensors are incorporated with that patient for monitoring the health condition of that patient. The data is generated. The data is sent to the cloud or medical servers with the help of these network layer actions, Zigbee network, Wi-Fi network, wireless network, cellular network, and WiMAX networks. With the help of these communication networks, send the data to medical servers. Access networks includes access networks, that means digital subscriber line, hybrid fiber coaxial lines, satellites, GSM by edge, UMTS, terrestrial radio access networks, evolved UMTS, terrestrial radio access networks, wireless LAN, worldwide interoperability, microwave access. These are the networks. These are the access networks. Core networks. A network that provides the following capabilities. IP connectivity at a minimum. Possible other connectivity needs. Service and network control functions. Interconnections roaming. These are the core network functionalities. With this IoT architecture outline is completed. This is the sensing layer, network layer, data processing layer, application layer. In the sensing layer, we use sensors or actuators. Sensors are used to collect the data. That is called as data gathering. Internet gateway, internet network gateway, network technologies. Once the data is collected, the data is called as raw data, analog data. Okay. Internet gateway is the mediator between the core, mediator between the cloud, not core, cloud, and the sensing layer. It performs some actions, converts analog data into digital data, converts raw data into useful data, data aggregation, like that. All are takes place at the data processing layer. Finally, the important data is sent to stored in servers, medical server, medical servers. Here some servers are used here. Pollution data aggregation server, weather server, police video server, security monitoring server, traffic server, medical server. All the data is stored in the servers and collect the data from these servers. With this IoT architecture outline is